Good morning, Trig. Hopefully you're tuning in with me this week, especially this is lesson 13, but lesson 14, the video will be pretty much mandatory because we start getting into some non-review material. Lesson 13, I think is not last, but this is still review. We start getting into some new material, lesson 14. So lesson 13 is a review of secant, tangents, and chords. So I'm going to go over a couple things that are really important about a circle. Whoops. Yep. Okay, so if I have a circle, and that is my center, then an angle that is formed using the center is called the central angle. And that should pretty much make sense, right? And then the difference, so you have a central angle, and that central angle is at the center, but this outside portion of the circumference is your arc. Okay, so that is super important. Your central angle, arc, center. Another possibility, the difference is an inscribed angle. Now, I should talk about a central angle and the measure of the arc will be equal to each other. So notice central angle will be equal to its arc. So if this is 60 degrees, the arc is 60 degrees. Now this, if you have an angle touching the outside, that right there is an inscribed, and I should have pointed, that right there is an inscribed angle. Notice the difference. Central angle is at the center, an inscribed angle touches the outside and is formed by two chords. Right, this is a chord. It goes from one part of the circle to the edge. It shouldn't go past. Okay. Now, what's important here is that an inscribed angle. Hi, my spelling today. And again, sorry, you have your arc. When it comes to an inscribed angle and the arc that it forms, the inscribed angle will equal half the measurement of the arc. So central angle and arcs are equal. An inscribed angle and an arc, the inscribed angle should be half of the arc. So that is the first part. That should be review. The second is the difference just between your chords and secant tangent. So I'm going to go over the three. So this is an example of tangent line. It only intersects a circle at one place. I should put point. A secant line will intersect in two spots or in 2 points. And so we're going to do some examples going over the properties that are covered in this section of the book. So in 13.A and 13.B, they're going to review the properties of tangents and secants. I think 13, yep. So we're just going to do examples as I go covering these properties. So number 1, if I have, this is an example where I have two secants that intersect inside a circle. And the rule here is that, and I'm just going to go over it, so I'm going to label this. This arc here is 30 degrees, angle X. This arc over here is 90 degrees. Now, really quick, these are vertical angles, so these are both X. So this property states that the sum of the two arcs, so 30 plus 90, divided by 2 will equal your angle on the inside. So notice this is the sum of arcs. Okay, so 30 and 90 make 120, divided by 2, the inside angle equals 60 degrees. So X equals 60 degrees. It's not a central angle, it's not in the center, but yeah, these equal 60. The next property it covers, I'm like stumbling over my words, I apologize. If the secant lines intersect outside the circle. So let me see if I can get this straight. So this is two secants that intersect outside a circle. Okay, so an example here, the difference. So up above, notice we added our arcs. When they intersect on the outside, it's going to be the difference divided by 2 will equal X. So 60 over 2 equals X, so X equals 30 degrees. So if they intersect on the inside, you find the sum of the arcs and divide by 2. If it intersects on the outside, you find the difference and divide by 2. All right, the next couple are going to have to do with a secant and a tangent line. So number 3. So if I have, that is a very large example, I apologize. If I have a tangent line and a secant line, so here's my outside angle. This is 70 degrees. This out here is 140 degrees. Now, I hope you know I haven't been labeling, but here's an arc, and then I have this large arc. Okay? So in this case, I have a secant and tangent intersecting outside. And in this case, the same as before, because they are intersecting on the outside of the circle, you're going to find the difference, divide by 2, and that will equal the outside angle. So again, it's the same as when you had two secant lines. It's the difference of your arcs divided by 2. So I have 70 over 2 equals X, so X equals 35 degrees. All right, next one is going to be a little bit harder. We're going to do a little calculating. So again, I'm going to do a tangent line and a secant line. I'm going to tell you that this is X, this is Y, and this is 180. So I have this arc here, which is unknown, and I have this arc here. And I'm also going to tell you that this arc down here is 150. So the first thing I have to do is solve for y, okay? So I know that an entire circle is 360 degrees. So 360 minus the 180 minus the 150 should equal y. So if I worked my way all the way around, this portion here is 150, this portion here is 180, and this portion here is y. So if I subtract 180 from 150, I believe that's 330. So that would mean that 30 degrees equals y. And then I can solve for x. So the difference of my two arcs, so 180 minus 30 divided by 2 equals x. So notice I didn't use the 150 because those aren't part of my outside angle. So if I'm looking at my outside angle, I should only be involving the yellow arcs. So I'm involving the angles that actually that are being formed. I'm involving the arcs that are being formed by angle x. So that gives me 150 divided by 2 equals x. So x equals 75 degrees. All right. You know what I'm going to do? Oh, no, we're going to move on to 13.c, which has to do with chords. Now, a little review. Chords are formed from one edge of the circle to the other. They do not go past, and they don't go on the outside. So chords should go from one point to another. And so we're going to jump right in. If I have two chords that intersect on the inside, so if this segment is, whoops, that's not an angle. Sorry, I out of habit put the degree symbol. And this segment is 40. And this here is x plus 10. And this one here is x plus 20. If I have two chords that connect at any 2 points on a circle, the products of chord segments are equal. So for example, and I'm going to keep them chord segments, so the green chord would be 30 times x plus 20. And that must equal the product of the yellow segments. So you set them up together. So the product of the yellow segments would be 40 times x plus 10. Okay? So 30x plus 600 equals 40x plus 400. I said 40x and I wrote 4. My apologies, I'm all over. All right, so I'm going to subtract 400 and that gives me 200. I'm going to subtract 30 and that gives me 10x. So if I divide by 10, x equals 20. Okay. Now, last part of this section has to do with secant segments. And so here is the last part of 13. And I'm going to keep track of what example I was on. So 13.d has to do with secant segments. Okay. Oh, you can't see that. And I'm going to take a quick drink of coffee. Forgive me. So, I think I'm on 7. So if I have a circle, and here are secant segments. And so I'm going to go over the property first. So if this is A, and this point here is A, this point here is B, and this point here is C, this is D, and this is E. So I know that the product of CB times CA has to be equal to CD times CE. So they're saying that I'm using CB times CA and CD times the whole segment. Those two have to be equal. So I'm going to give us an actual problem to work here, and then here comes Arroyo.
I'm looking for Miss Barnhart again. She's going to be here tomorrow, right?
Right, we switched because my daughter has surgery.
All right, sorry.
It's okay. So I'm going to give us some measurements. So CB is 6 times CA. So CA would be x plus 6, because I would add them to get the total distance of that line. And that must be equal to CD, which is 4. And then this would be, the whole segment would be 10 plus 4, so 14. Okay, I would distribute, so 6x plus 36. 4 times 14 should be 56. So I'm going to subtract 36 and I get 20. Divide by 6 and x equals 10 over 3 because we always reduce our fractions. Okay. Now this one is secant segments. Okay, so hopefully you can see the difference. And I probably should have titled this different. This should be secant segments, and the next problem is tangent segments, or tangent and secant segments. So number 8, the last one for today, or for this section, I have secant and tangent. So this is a secant and tangent segments. So I hope you noticed the first part of 13 had to do with angles and arcs, and now I'm working with the actual lines. So if this is x and this is 8 and this portion here is 12. Okay, so I don't need to label. Now, the property here is, it should be, well, I guess I could label. This is A, B, C, D. So here we go. The product of BC times AC should equal CD. So that your secant segments should equal the tangent. Okay, so these are your secant segments should equal the tangent line. So that means x times x plus 12 will equal, this should be squared, will equal the tangent line squared. So your secant segments, the product of your secant segments equals your tangent line squared. And I guess we don't need this portion here. So if I distribute, I get x squared plus 12x equals 64. So x squared plus 12x minus 64 equals 0. And you can either solve by factoring or the quadratic formula. It's really up to you. I'm going to factor because I think it's faster, but I can show you both. So negative 64 and 12, that would be 16 and 4 and negative 4. So x plus 16, x minus 4. So x equals negative 16 or positive 4. I can't have a negative 16 segment, so the answer is only 4. Okay, or you could have used the quadratic formula. Now, for homework, you're going to skip, I want to put these in order, number 3, 10, 23 through 25, and 27. And that's it. Thank you.